All right, it looks like we have some more folks joining. Welcome, everybody. Thanks so much for being here with us this morning. Feel free to drop an introduction in the chat. I know some folks have been together in rooms already this morning, but always nice to just be able to confirm your name and maybe where you're coming from. Feel free to share your role. Just always helpful to make some connections, and we'll get started here. So this is the session all about state and district computer science education data and tools. This will be an interactive session where we will engage you all in doing a little bit of data lookup about your local area, and I will invite you to do some breakouts, I think, if that's possible. So we are excited to have you as a part of this session and look forward to the ways that you'll be able to dig into some of your data in order to really make meaning with kind of how computer science plays out in your area. If you haven't had a chance to have a session with us, my name is Andrea Vazquez. I'm the computer science specialist at the Minnesota Department of Education, and I'm joined here with my esteemed colleague, who I'll let introduce herself.
Hey everyone, I'm Jen Rosato. I am the director of the Northern Lights Collaborative for Computing Education at the University of Minnesota, and happy to see folks here today.
All right, and I see some introductions coming in the chat. Awesome, keep those coming. Thanks so much for being here, folks. It's fun to see some familiar names and faces as well. So we wanted to kick things off with a question. Feel free to unmute if you'd like. This is a super small group, so definitely welcome your voice in this space, or if you're more comfortable in the chat, that's okay too. We're just curious to know, thinking about data, what kind of data is included in measuring access to participation in an experience in computer science education? And in what ways can data inform your district's plans? So just kind of curious about that. If you've got any inklings or information about different kinds of data that could be included in doing some of the measurement of those different aspects of computer science education, and in what you think how data can inform your district's plans.
I think it will help us understand the opportunities that are available to add value to the goal of uh, expanding, computer science education to kids of all levels. So it will help educators identify the gaps, provided they have the relevant data, which is coming from the analysis and surveys.
Absolutely.
Yeah.
Yeah, thank you so much. That's a super important point. So knowing what's available in order to help identify where gaps might exist, or where some new opportunities could help fill in. Yeah, thank you for that. And I see in the chat some ideas about curriculum integration is a spot. Yeah, absolutely. Enrollment demographics, tell us who has interest or access to computer science courses, how we might invite others. Great. Love that. Yeah, we will also, spoiler alert, we'll provide some ideas later in the presentation. So if you're thinking, I'm just not exactly sure yet how this can happen, stay tuned. We'll make sure to walk through some of that together. And we'll also, of course, be interested in hearing your expertise and experience as well. So if there are other tools that you've used, we'll be curious to know that. So as we're getting started here, if you were in the session with me earlier today, we had kind of a similar discussion. We're going to take this one a little bit deeper. So again, in the chat or out loud, just curious to gather some kind of collective responses here around the question, what is computer science? So as you're thinking about and talking about computer science, as you're sharing your excitement for computer science with others, and as you are trying to quantify how much computer science is happening, what qualifies as computer science, the definition of computer science is a really important thing to have common understanding of. So just want to kind of gather some collective responses here. When you think about computer science, What do you think of, or what comes to mind? Not all at once here. Come on now. It's crowded in the room.
So yeah, so when it comes to computer science, one is the hardware that supports running the code, then we have the middleware, and then we have the software. So the general perception is computer science is all about software, but it is not the case. And that being said, um, the components that make up a motherboard, like the processors that we use, um, the transistors, the type of connections, the service buses, understanding the underlying hardware helps us to design code better. So in today's times, what I feel is there's always a gap between embedded system design engineer and a software engineer. Of course, both require extensive work to gain that experience to be able to produce efficient work. But having an engineer who is a blend of both would be a star, is what I feel. And when it comes to coding as well, generally, even when I was in school, I thought Java is the only language that existed. But there are languages like C, C sharp, assembly, Cobol. All of these are used to design the mainframes and train the hardware components. Um, and they carry huge amount of weightage. That's the one aspect. And when it comes to computer science, with the advent of artificial intelligence, it is evolving a lot. It is undergoing transition. It is becoming available to everyone. We have Copilot, we have GitHub Copilot, we have Microsoft Copilot, and learning has become more accessible in today's times. That is what I can assure. Um, and yeah, I mean, it's good, and also it also covers the cloud computing aspect, because I did my master's from Indiana University Bloomington in computer science, and we had courses like distributed systems and artificial intelligence, machine learning, all part of the curriculum. So that being said, it is important to let students know, especially the budding kids like the high schoolers or intermediate, or undergrads or grads, the options that are available outside in the job market, so that whatever they are learning, they are keeping that perspective of having a long term gain.
Yeah, thank you so much for that information. Yes, I heard you mention some important pieces there. Thinking about it goes beyond the software and the coding to the really thinking about the hardware, as well as artificial intelligence and cloud computing and the ways that all of these things impact our lives every day. Yeah, great. Thank you so much for those contributions. Also looking in the chat, I see some ideas about critical thinking, learning the rules and techniques to build and design all sorts of things with computers. Nice. Yeah, a good chat GPT prompt. Nice. That's awesome. Thanks for sharing. Collaboration. Absolutely. Absolutely. So, as you may be aware, there's a technical definition for computer science out there. This is generally a definition that's been adopted across many states and in many contexts. In Minnesota, this definition has been used in our legislation for the 2023 Computer Science Education Advancement Act. It's drawn from the K-12 Computer Science Framework, as well as the Computer Science Teachers Association standards. So you'll see it in many places, but it is rather dense, or at least has some of that technical vocabulary, thinking about kind of to pull out a few key pieces, the algorithmic processes, right? Hardware and software. There's a nod to hardware and software designs, and kind of how they're implemented, and then the impact of all of these things on society. And so what we wanted to do today is we wanted to sort of have a collective poll of our knowledge, and we're going to do that using a Kahoot. So if you would be so kind as to navigate on your device to kahoot.it in any internet browser, I'm going to do my best to navigate to the control panel here. Got it. And once you're at kahoot.it, you'll be able to type in a code. And I should be able to give that to you in just a moment here. So no shame if these questions are more challenging than you anticipated. We'll have a little bit of discussion, but we'll also in your breakout rooms invite you to kind of share together about what came up that you were thinking like, oh, that was or wasn't computer science, and I was perplexed about that. So I see some people joining now. Again, that game pin is right up at the top, so that should allow you to join. All right, give just another moment. All right, there we go. Got another person or two joining. Nice. Okay, I'm gonna go ahead and hit start. And here we go. I'll help read them out loud. The general premise is computer science, yes or no? Here's this first one. True or false? Performing an internet search is computer science. Okay, so the answer is that is not computer science. The act of, as a human, performing an internet search, searching something up on Google or Bing or any internet search engine of your choice, just doing the general search is not computer science. We've had some discussion, and I can see people's perspectives that understanding how an internet search works is computer science, or potentially crafting your search in order to test out different algorithms. That could be computer science. But just the general act of telling somebody, oh, Google this for me, that part is not computer science. That's technology use and an important skill, but it's not computer science on its own. Okay, let's check out this next one. Oh, we've got our leaderboard. I almost always forget about the leaderboard. So we've got X as the individual to beat. See how we do. Here we go. Okay, again, true or false? Designing a paper prototype for an app to solve a community problem is computer science. All right, so we would consider that computer science because you're going through the design process to consider probably the user interface and what kind of content you would want to include. You're probably thinking about some algorithms in terms of how you want the interaction to happen and kind of a flow chart of maybe if this is clicked, what would happen. So we would consider that computer science. The actual design and implementation of the app would also be computer science. Let's see how our leaderboard is looking. All right, a little bit of a shift. Here we go. Let's see what the next one looks like. True or false? Downloading and installing new software is computer science. Okay, so I see the most of us are saying false. I would tend to agree, especially if we're thinking about this just as a surface level action where you are, let's say, downloading and installing a new app on your phone or tablet, or installing a new program on your laptop. This does not mean mass installation on many devices. It doesn't mean understanding how the download or install process works or having to do anything in the command line. This is just a simple download, and that action itself is not computer science, although it is an important technology skill. Ooh, our current leader is staying in the lead. See if we can switch it up. Here we go. True or false? Writing down a set of steps so that someone else could build a predetermined Lego structure is computer science. All right, we're getting some common answers here. So yes, we agree this would be considered computer science. It's helping to identify an algorithm, a set algorithm, that in this case could be given to somebody else to build a Lego structure, but that skill also can transfer then, of course, into writing programs for a computer to follow. So that is considered computer science. All right, got another leader approaching. Here we go. Let's see this next one. True or false, discussing the ways that biased artificial intelligence impacts our lives is computer science. Yes, so this one is considered computer science. This one falls under the impacts on society or impacts on our lives. So thinking about artificial intelligence as a part of computer science and the biases that it brings and the ways that that impacts our lives, that really does fall underneath that impacts of computer science area of the definition. So that one is computer science. Okay, here we go. Next one. True or false, using a programming language to write a function that can draw a regular polygon is computer science. Yes, we had a lot of common agreement there. That one is computer science. It showed a picture of Scratch. That's probably one of the most traditional kind of images that might come to mind when thinking about computer science is the programming piece. So yep, that one is considered computer science. That falls under the algorithmic processes. And probably software. Yeah, for sure. Okay, I'm getting to the end here. True or false, learning how to type or use a mouse is computer science. All right, a lot of common agreement there. Agreed. That one is not computer science. Just the simple action of learning how to type on a keyboard or use a mouse, those are not considered computer science. Again, those are important technological skills that all students should be able to show their mastery of, but I would say they're not computer science in and of itself. Having a further conversation about how a keyboard interacts with software or how the hardware of the mouse interacts with any software on the computer, those conversations can approach things that are covered in computer science. But just the simple act of learning how to type letters or how to click a mouse, those things are not considered computer science. Again, important technological skills though. Ooh, we've got our constant leader. Let's see if these last two questions do anything about that. What do you think? Designing a Google Slides presentation is computer science. All right, so this one is not considered computer science. The simple kind of filling in of content, let's say for a book report or, all about me sort of a project, the filling in of information is not computer science. I have heard arguments before stating that sometimes people might use a slide deck as a prototype for an app or for another computer program. If it's used in that way, I can see where a Google Slides or a slide deck could be a prototype, could be computer science. But the simple filling in of content on a slide deck is, while an important technological skill, is not considered computer science. All right, Holly, this last one, this is your chance to edge out the current leader. Let's see, true or false. Creating a digital animation using a block-based programming language is computer science. All right, a lot of common understanding there. Yes, that is computer science. Again, that's probably one of the more common images that comes to mind. So let's see how our leaderboard stacked up. Hey, congrats to our leaderboards there and the runners up, and thanks so much for participating in our Kahoot. Just a fun option if you're interested. I'll drop a link in the chat, a way that you can talk to folks about what is and isn't computer science, and certainly things that are common images, the things that many of us got right, and then also some common misconceptions, and so a helpful way to discuss. All right, I'm going to close those tabs so we don't have the Kahoot music playing all the time, even though it is kind of fun. All right, so with that, I want to just make a transition now to mentioning, and this is, again, something that I shared in a previous session, as we're looking at this data today, and now that we have a common understanding of what computer science is, really wanting to hone in with our lenses, our equity lenses, knowing that computer science has historically been an exclusionary field of study and field of practice, really wanting to embrace the idea that every conversation that we have about computer science education and within computer science education is a conversation about equity. So inviting you to really embrace some of those lenses today as we're looking at this data and as you carry this information forward. One additional lens, or one way that those of us on the computer science working group really looked at the data as we were considering kind of how to slice it up and how to really think about where gaps and opportunities might reside, was using this CAPE framework. This is a tool for evaluating the equity within computer science education ecosystems. It was developed out of the University of Texas at Austin, and has a lot of really important applications. You'll see there that the base of the pyramid is all about the capacity for computer science education. So thinking about educators, thinking about infrastructure, thinking about policies, all of that capacity piece really sets the foundation for the ecosystem to be as equitable and sustainable as possible. It goes on then to access to computer science education. So thinking about where computer science courses are offered, if courses are offered in one school within a district and not in another, or in one classroom and not in another, how students can gain more equitable access to computer science. And then thinking about who's able to participate in those courses, or who is signing up if they're electives, and looking at the demographics of computer science courses or computer science learning opportunities as compared to the demographics, overall demographics of the school. Thinking about any barriers to participation is a big piece there. Scheduling is a big piece. And then finally, the experience of computer science education. That's really honing in on each student's individual kind of experience and success within the course. So you can look at student outcomes, you can look at students' kind of perception of how they feel in the course, their feedback after the course, if they choose to go on and take further computer science courses, and kind of how those responses compare across different subgroups are really important. So we just have a chat there. We want to encourage you to consider, and you can type in your response into the chat, but not quite press enter yet. We'll aim to all press enter at the same time. So how could any of these CAPE layers inform your district CS Ed plans, or CAPE in general, if you'd prefer? So think about that. How could CAPE, this CAPE framework, help to inform your district CS Ed plans? So go ahead and enter your response into the chat, and then we'll all press enter at the same time. Maybe another 30 seconds to type. All right, when you're ready, go ahead and hit enter. How CAPE data can help us to inform CS plans. Yeah, direction, for sure. Not a blank slate. Looking at access. Yep. Sustainable, responsive system. Yeah, great. Thanks for those ideas. For sure. For sure. Find the gaps. Absolutely. That was a big kind of area that was outlined in the legislation last year in terms of what the working group was asked to do with our computer science state plan, was to present some kind of landscape data, what's happening with computer science in our state, and identify the gaps. Of course, that's a really big deal in terms of being able to then identify opportunities. How do we fill those gaps? And we can't take next steps unless we know what they are. Yep, and what is already happening in the district. Absolutely. Great point. Great point. Yeah, awesome. We're going to now start to dive into the data portion. So we've got some really good background. We've got some common understanding. We've got that CAPE framework to help us to think about the different layers. So I'm going to pass it now to Jen to tell us a little bit about some of the data. And while Jen is introducing those, I'm going to run and grab my laptop charger. Jen,
Okay.
take it away.
Thanks, Andrea. So all of the data sources that we're going to cover today are public data sources. The data was gathered from the Minnesota Department of Education by school districts submitting it to MDE, and then we've just shared different ways to visualize the data. So much of it can be accessed through the MDE Data Center website, which if you haven't explored it, actually has a ton of information available. And one thing I've learned by working with states in on computer science, other states in computer science education, is that Minnesota actually has a great system for data in terms of we collect a lot of data that other states don't. Like some states don't collect whether or not students have disabilities and make that a publicly shareable piece of information. Some states don't collect the outcomes that students have in courses and whether or not they pass or fail a course, but we do. So it's great that we have a rich data set to work with. So we're going to take a look at the Minnesota report card so that you can understand how to find your own district demographics information to know what your district looks like. Then we're going to take a look at the Minnesota Common Course Catalog data and some of the visualizations of who is offering computer science and who is not, and what computer science courses there are available. However, a caveat here is that not all schools actually submit their data to the Minnesota Common Course Catalog. So about half of the schools in Minnesota do that. So you may not be able to find your school, but you could possibly find a neighboring district or school instead. And hopefully there will be more schools submitting data with some updates that MDE is making to systems so that they hopefully work a little bit better with school data systems. We have 2 data reports that have computer science information that are on the MDE Data Center website. So we'll talk through those. And then this is an external project that happened, but we worked with the Minnesota Department of Ed, including Andrea and some of the data team, to be able to develop this visualization of access and participation in computer science courses. And then there's some data that I'll share that's also in the Minnesota CS Education Landscape report. So that's a quick overview. I'm going to show you the tools just very briefly and then hopefully give you some time to interact with them. So Andrea, if you want to go to the next slide, I'll just show you each of those. So first, to center ourselves in terms of what are the demographics of Minnesota, we have over 500, almost 600 public school districts. We have almost 900,000 students and we have over 100,000 teachers. No surprise, it's roughly half male and half female. No surprise also probably that white students make up the largest demographic in terms of race and ethnicity in our state. And there you can see the percentages for some of the other groups. And then the chart in the bottom right shows percentage of students in Minnesota that qualify for free or reduced meals. That percentage surprised me. I didn't think it would be 43%. I thought it was going to be closer to the 20 to 30%, but it's almost half of our students. We have almost 1 in 5 students who qualify for some sort of special education service, whether they're on an IEP or a 504. Almost 1 in 10 students who are learning English. And 1% of our students are homeless and don't have, home base to go to every day. So that gives you kind of a picture of where we're at. And then we hope that you can use, your district to establish where your district is at by looking at your report card. In the next slide, so this gives us some ideas of data that comes from the state landscape report. So this is from the Minnesota Common Course Catalog, and this would be experience data. I've included this directly in the slides here because you can't access that through any of the tools that are available online. I had to make a special request as part of working on the landscape report to get the data from the state and then be able to compile it. So the courses that you see here have some categories. None of these are just a single course. There's basic CS courses, advanced CS courses, things that we might consider core CS, like foundational, and things that are CS related. And then some other kinds of different, like what are the categories of CS related, like networking and robotics, where it might not be core CS. And this shows you some of the pass rate by the type of course, and then it also shows you the pass rate by the region in the state, the different economic development regions. So I'm in Duluth, Minnesota, and now I'm totally going to forget. I think we're region 1. If I remember right, and you can see our pass rate there is 91%, but it's roughly about the same across the state, which is great to see. And I see there's a question in the chat, is basic CS different to core CS? Yes, basic CS is like an introductory CS course, and advanced CS means that you had to take some kind of intro CS before you could take the advanced course. So core CS could be basic or advanced. So if I have programming 1 and a programming 2 course, they would both be considered core CS, but programming 1 would be basic and programming 2 would be advanced. And then Andrea, on the next slide, there's information for AP data in term, oh, whoops, apparently not. I think I have a mistake in the order of my slides, but that's okay. This is the Tableau dashboard for the data that was for that external project. So we'll give you the links here in just a minute. But this is where you can access visualizations of which schools in the state are offering what kind of CS courses, basic, advanced, core, CS related, that kind of thing. What the demographics are of the students who are taking those courses, so who enrolls in it, and then what that enrollment looks like by your school. So it's very interactive. You can look lots of stuff, but again, if your district doesn't submit data to the state, then you're not going to be on there. So just that caveat. And next. Yeah, something out of order here. My apologies. This is the AP pass rate data. And so you can look in that by different race and ethnicity groups in the chart on the left, and then how that varies by gender and how that varies by some of those other Minnesota Common Course Catalog, not AP, and how that varies by some of the other groups that we looked at the very beginning. So there are definitely disparities and not as even as some of those other like regional data that we looked at. All right, next one. Okay, here's the AP data. And the reason we have this here as well is because this is accessible across the country. You can look it up for your state. You can look it up going back 20 years or more. Passing an AP course counts as getting a score of 3, 4, or 5. And you can see on here in terms of looking at gaps and where we might have gaps, male students pass the computer science principles exam at a 77% rate, while female students pass it at a rate of 84%. So that might surprise some people that female students pass the CSP course more often than the male students do. Another thing that I want to call out in terms of looking at some of these numbers is that there are some very small numbers of students in some of the groups who participate in CS courses, which is probably not a surprise to us. But when you think about percentages, like 60% for Native American students in AP-CSA and 83% of students in CSP, that's really just a difference of one student in these courses. And so you have to be careful with some of those percentages. All right. And then on the next slide, here's the Minnesota report card. This is the link that we'll share where you should be able to look up your school. And then if you click on the who are the students, that will give you your district's demographic information. So you can see like, what does your district look like as a whole and how might it differ from who is participating in your CS courses? And then the two STEM course reports that MDE has available. One is called availability and one is called enrollment. Availability indicates whether or not a course is being offered at that district or in that school. And then enrollment tells you about the demographics of the students who are enrolled in that course. For these, there is computer science in the list. It is a limited set of courses. So the other data sets that we've been talking about, it's all the CS courses. For this one, it's a very limited list of, I think, like 5 or 6 courses. Intro CS includes exploring computer science and computer science principles. Advanced CS includes computer science A and I think one other programming class. And then information tech includes some like networking and basic kind of CS help desk sorts of courses. So it's a limited set. And so you may not find your course in there either because it may not have been coded properly. And then let's see. So if we go to, yes, the slide. So I'd like us to stop for a moment before we start looking at the data and think a little bit about making a prediction in terms of which student group do you think is most likely to be very interested in learning computer science? White students, Black students, or Hispanic students? And white is A, Black is B, C is Hispanic. Okay, so we've got one who's guessing white, another is white. Oh, all of the above. Well, Google and Gallup did a study a couple years ago, and the data actually shows, and do you want to show this for me, Andrea, that Black and Hispanic students are more interested in computer science than white students. Hispanic students the most, almost double the amount that white students are interested. However, they don't have as much access to computer science courses. So when you look at enrollment information, it can look deceiving because they don't have the access, and so they are not able to take the course as often as their white peers, but they are very interested in taking computer science. Okay, so we'd like to give you a little bit of time, and let me just look and see how much we have left here. Not a ton of time, but a little bit. We'll give you some time to maybe take a quick peek at some of the data sources and just explore those. I would say if you have one choice to look at something today, I would click on the ESEP Access to Computer Science courses link. And I just dropped in the chat there the link to the slides. I'll also drop in the chat the link to this ESEP Tableau page here too, if you want to go directly to that and just do a little bit of exploring around and think about what gaps you might see, what might surprise you in the data. And if you have any other questions, we'll skip the breakout rooms and just give you a minute or two to look at those. I think I might have taken Andrea's slide here. Sorry, Andrea.
No worries at all. No worries at all.
I would also just invite you, if you have any questions about those data sets, to drop them in the chat or feel free to unmute and ask, as now is a good time to ask those. Ooh, thank you. We'll fix that. We were going to have you go into breakout rooms and type responses in the slides, so that's why they were editable.
All right. We know we didn't give you as much time as you could probably use to really dig into some of those tools, but hopefully you had a chance to at least click into one of them. We want to just give you a chance, anybody who's willing, to share anything that stood out. Did you come across any data that surprised you? Did you see any gaps? Were you able to identify a local school district or maybe even your site in some of the data? Yeah, just interested in hearing from anybody who was able to try out one of those tools. And also just acknowledging that we give you a very short time. So if you're still exploring, that's okay too. I was thinking, so this is the link that we had said you may want to check out. I just wanted to give you a quick view of what it looks like. So thinking about like access to computer science courses, this is where the map comes up. And where you're able to kind of identify the different course levels and the different categories. Again, this is where there might be some limited data. So you may find, just more limited information, but where you can kind of say like a basic course, and you can see like basic computer science, how many courses are offered in different kinds of schools, and you can see where basic courses are offered. And this is, again, where you're able to kind of hover and see if any data has been submitted. So here, Moorhead High School has 2 basic computer science courses and 2 advanced courses. So just thinking about kind of some of the ways that this information could be helpful, and where it could also continue to be more helpful as we gather more information. But I'm just thinking about like, who do I know in Northwest Minnesota, or how can I do some outreach toward folks kind of in this middle zone right here, where it's surrounded by schools that are teaching, but maybe there isn't a course offered yet, or thinking about a little further up toward the Iron Range, like what do we got up there? So anyway, just wanted to give you a quick preview of some of that information and that particular tool, as well as just to call out the availability of some of those other links as well. Oh, and this is where we were gonna invite groups to go into breakouts. That's okay. So just thinking about some of the ways that course information is submitted. So I'm just curious to know, does anybody here know who from their school submits information on courses on your course catalog to MDE? Just curious if anybody knows who that person is in your school or district. So we know that sometimes those people are school counselors, sometimes maybe it's a technology director, sometimes it might even be a school secretary. And just thinking about kind of what we know about the definition of computer science and how many pieces both fit into computer science and how many pieces are misconceptions about computer science, it can be really hard for that person to make the call about whether a course would be considered computer science or not. And so just as a piece of homework, I want to encourage you to just do a little bit of digging to find out who it is that reports the data on courses offered to MDE from your school, and just maybe have a conversation with them about computer science, what you know about computer science, and any courses that might be offered at your school, so that they can feel more confident, and so that we can kind of work together to have the data as a best reflection of what's being offered in our schools. It is no small feat. It will take us all working together in order to really help capture our data as accurately as possible. MDE will continue to put out information as as we have it developed. I know they're switching over to a new system now, which hopefully should be more helpful. And we'll do our best to have more information and support available for you and your schools and districts as we can. So with that, in our final moments, would love to invite you to share any learnings or key takeaways from today. If there were any links that you didn't catch yet, we'll be sure to share those. We can also put our contact info in the chat one more time. Any key learnings or takeaways from today? Yay, data tools. There's my email as well. Yeah, and I saw Jen put in there any questions with CS Data, feel free to reach out to her. I'd be happy to be a resource if you're having any questions about what is considered computer science or using kind of some of the course names in the Common Course Catalog to help you as you're thinking about which courses are already being offered or might be offered in the future that could qualify as computer science. Happy to connect with you about that at any time. And so with that, we'll say thanks again for coming to our session. Thanks for being here today. My understanding is I think there's a common gathering back in the main Zoom room for a last farewell. So we'll see you over there. Thanks so much, everybody.